An element you can find in your kitchen used to be more valuable than gold. I'm Sanjana Curtis and this is Stardust, a series where you and I will do a deep dive into the elements of the periodic table, where in the universe these elements were created, astrophysically speaking, and their role in our lives here on Earth. Our element today is aluminum. Aluminum has 13 protons in its atomic nucleus and two naturally occurring isotopes, aluminum-26 and 27. Aluminum-27 is stable, but aluminum-26 is radioactive, with a half-life of 717,000 years. This is a long time for us, but a short time for a star. Both isotopes of aluminum are produced in massive stars, meaning stars more than 10 times as massive as our Sun. In these stars, aluminum is produced through carbon burning or neon burning. And please remember, when I say burning, I do not mean fire, I mean nuclear fusion reactions. The aluminum a massive star deposits into the interstellar medium is some combination of aluminum produced during the star's life and that produced during its explosive death. It is not easy to disentangle exactly how much aluminum comes from which process during which phase of a star's evolution, but it is important to figure this out if we want to learn something about stars by observing, for example, the amount of aluminum-26 in the galaxy. When aluminum-26 decays, it produces magnesium-26 and a highly energetic gamma-ray photon. These gamma-ray photons allow us to make a map of the aluminum-26 in the galaxy. And here is the map. This was done by Comptel and Integral satellites, and I want to emphasize this is really cool. You can't just do this with any old isotope of any element. We are able to see aluminum-26 because of these gamma-ray photons that it produces when it decays. So what does this map tell us? A couple of things. First, aluminum-26 is continuously being synthesized in the galaxy. Any aluminum-26 that had been produced a long time ago would have decayed away by now, and we would not be able to see it. So the fact that we are seeing this aluminum-26 means that it was somewhat recently produced. Second, there is an extensive overlap between the location of the aluminum-26 and where massive stars are known to live. So this establishes the link between massive stars and aluminum-26 production. On Earth, aluminum is one of the most common elements in the crust after silicon and oxygen. So how did it end up being one of the most expensive elements in the 1800s? This is because in nature, aluminum does not exist in its pure elemental form. It exists as various compounds, and important ore, for example, is bauxite. So aluminum is difficult to extract and isolate. German chemist Friedrich Wöhler was the first to isolate aluminum in its elemental form in 1827, after decades of work by very prominent chemists. He found a silvery white, lightweight metal that was both soft and malleable. In the years after aluminum was discovered, it remained a very rare metal because of the difficulties with refining it. And that's why the price of aluminum for a short time exceeded that of gold. King Christian of Denmark had a crown made of aluminum. Napoleon III is said to have, at dinners, given his most esteemed guests aluminum utensils rather than silver or gold. Even the Washington Monument in 1884 had its capstone made of aluminum. Around that time, aluminum was about as expensive as silver. Once the industrial production of aluminum began, prices started dropping, and now the metal is commonplace. It's mostly found as alloys because pure aluminum is rather soft. However, alloyed with copper or silicon, you get a metal that is both lightweight and strong. That's why aluminum is used in so many things in today's world, and if you're planning to time travel back to the 1800s, I recommend carrying some aluminum foil.